2x plus 4 and f of 3. I'm trying to find f of 3. Well, that just means x equals 3. So you just plug it in. 2 times 3 plus 4. 6 plus 4 is 10. So f of 3 is 10. This just means x equals 3 and y is going to equal 10. So f of negative 1, that just means x equals negative 1. So that's 2 times negative 1 plus 4. That's negative 2 plus 4, which is just 2. So f of negative 1 is 2. Okay, arc length is just a piece or part of the circumference. So we can find circumference, the distance all the way around the circle. Well, if I want arc length, that's just talking about what percent do I want? How long is just this piece from A to B? We have a formula. Arc length is equal to theta over 360 times 2 times pi times radius, where theta is the amount of degrees because there's a central angle here. So how many degrees do we want out of 360? And then this right here is just the circumference formula. Then if you look at your sector area is just part of a circle that is bounded by 2 radius and its intercepted arc. Okay, this is you're looking at the area, so this is like a slice of pizza. So our formula is theta over 360 times pi times radius squared. Well, this is the area of the entire circle. Theta over 360 is talking about what percentage do we need out of the total 360. So let's do some examples. Find the arc length and sector area for each shaded region. Okay, arc length, that's just talking about circumference. It's talking about the distance from A to C. So if we find the entire circumference, which is 2 times pi times radius, and we take this answer and we multiply it by theta over 360, that'll give us our arc length. So it's 51 degrees out of 360. Okay, that's the percent that we want here. We're going to times it by 2 times pi times the radius, and it says B to C is 16, so our radius is 16. So we got our handy dandy calculator, or you can do this by hand. It would just take a little bit more time. 2 times 16 is 32. We're going to times that by 51 degrees, and then we're going to divide it by 360. And we get a really long decimal, so why don't we change it back into a fraction? So my fraction is going to be 68 pi, we're going to keep it in terms of pi, over 15. That's how much the distance is from A to C. Now, of course, the entire circumference around the circle is just going to be 32 pi, but we only want it 51 degrees out of 360. So if I want to find sector area, that's our area formula, which is pi times radius squared, but we only want a certain percent. Theta divided by 360 will get us that. So it's still 51 over 360 times pi, but my radius is going to be 16, and then we're going to square that. So we're going to leave this in terms of pi, so we're going to do 16 squared in our calculator. We're going to times that by 51, and then we're going to divide by 360. And when I get that, I get a weird decimal, so let's just change it back to a fraction. You can do that by hand, or you can do math enter on a calculator, and this is 544 pi over 15. Pause the video and try example 2 on your own. Are these the answers that you got? Try these two examples on your own. The area of a sector of a circle is 16 pi, so they gave us the sector area. We know the sector area is 16 pi. We know the measure of the sector is 40 degrees. What's the length of the radius? So we're trying to figure out what r is. So we're going to have to work backwards here. Okay, sector area, that's 16 pi equals, the formula is going to be 40 over 360. And since we're doing area, that's the pi times radius squared formula. Since both sides of the equation have pi, when we divide out pi, it disappears. And how do I move 40 divided by 360 to the other side? To move it to the other side, I simply multiply by the fractions reciprocal. So those cancel over here. Multiply 16 by the fractions reciprocal. So I have 360 times 16 divided by 40. So we end up getting 144 equals radius squared. To get radius, we take the square root. So my radius has to be 12. So over here, they're using arc length now. So they gave us what the arc length is. And they gave us a sector's 90 degrees. Can we find the radius? So arc length, that's going to be 4 pi equals, it's 90 over 360 times 2 times radius times pi times radius. So since there's a pi on both sides, when we divide it out, it cancels. I can move the 2 over by dividing it. So I'll end up with 2 equals 90 over 360 times r. And to get rid of 90 over 360, we multiply both sides by the reciprocal. Well, 360 over 90, that divides into itself. That becomes 4. Okay, these cancel out over here. And 4 times 2 is 8, so radius has to equal 8.